All right, this is the review sheet for the test coming up, covering lessons 4.1 and 4.2, and then most of chapter 3. So let's get right to it. This first problem, I'm seeing if you understand the exponent rules, how to take an expression like this and simplify it. So what I always recommend is do all the simplifying that you can inside the parentheses first, and then we'll take whatever that result is and raise it to the third power. So the fraction 8 over 24 would become 1 over 3. Here is a rule of exponents where I've got the same base being divided. I simplify those two x's and I make them become 1 by subtracting the exponents. So it would be x to the 2 minus 6 power, which is x to the negative 4. And then y would be to the 7 minus 2 power, which is y to the 5th. And then all of that is going to be raised to the third. Now you could go ahead, since we have a negative exponent, and we know that those have to be changed. And the way I change x to the negative 4, the way it is I move it to the bottom of the fraction, and then it becomes x to the positive 4. All right, and now I'm going to raise everything inside the parentheses to the third power. So here's another rule of exponents. It says that when I have a power on the inside of parentheses being raised to another power on the outside, this is when I multiply exponents together. So it'll be y to the 15th in the numerator. And then here's another exponent rule that says the product, two different numbers, variables being multiplied together, means that each one of these separately needs to be raised to the third power. So 3 to the third is 27. And then x to the 4th raised to the third would be x to the 12th. And so that ends up being your final answer for number 1. All right, so for number 2, I'm going to do the same approach. I'm going to simplify within the parentheses first. I can't really do anything with 6, so I can put these two a's together using the division property of like bases, so that becomes a to the 4th power. And then b would be to the 4 minus negative 2, which is b to the 6th power. The denominator you can think of as being 1. I'll just go ahead and write a 1 there. And then this negative exponent says to take this fraction below it and just flip it over. So negative exponents say to flip the base. The base in this case is this fraction. Flip it over. And then once you flip the fraction over, you can change the exponent to a positive. And now everything in the parentheses will be raised to the second power. So 1 squared is 1. 6 squared is 36. A to the 4th squared is a to the 8th. Remember that rule of power being raised to a power. And b to the 6th squared is b to the 12th. And there's your answer for number 2. Okay, so for number 3, I've had a lot of questions about this one, people thinking to use the distributive property. So maybe I can help you understand this a little bit better just by using regular numbers. So let's just pretend for a second that a is the number 2. And b is the number 3. They're just being multiplied together. I know they have exponents, but just for the sake of a simple illustration, I want to illustrate why this isn't the distributive property. Okay, so if I do exactly what this says, 4 times these two numbers being multiplied together, I would get 4 times 6. Remember PEMDAS, we do parentheses first. So 4 times 6 would be 24. If we do what some people have thought, which would be the distributive property, we would get 4 times 2, and then the distributive property would say you're going to add or subtract 4 being multiplied times the other number. So obviously, if we do this, we're going to get 8 plus 12, which is 20, and we don't get the same result. And then just a simple illustration as to why are we just multiplying 4 times the product. I've had some people that wanted to do this, multiply 4 times both. And if you do that, that's 8 times 12, which is 96. So hopefully this is an illustration on why we're just multiplying 4 times the product of these two, and we're not distributing the 4 to both terms, either through multiplication, or the true distributive property would be involving addition or subtraction. Okay, so with that said, when I multiply 4, I get 4 times a to the negative 2, b to the 7th. And then I'm going to multiply or raise both of these terms, a and b, to the negative 3rd. And now I'm going to multiply these together. So coefficients first, 4 times 1, that's 4. And when I multiply like bases, I add the exponents together. So a to the negative 2 plus negative 3 makes a to the negative 5. And then b to the 7 plus negative 3 makes b to the 4th. And then so the only thing that needs to be fixed here is this negative 5 exponent. And I fix that by just moving it to the bottom of this fraction, and then it becomes a positive. Okay, let's move on down to our next few problems. Same instructions to simplify. So number 4 is the distributive property. So I'm going to distribute 5xy to 2x. That's 10x squared y. And then 5xy times negative y, that's negative 5xy squared. And then I'm going to distribute 6y squared to x squared, 6x squared y squared. Just write your variables alphabetically within a term. And then 6y squared times 6 is 36y squared. And then you should always look for like terms, and don't see any like terms. So this ends up being your final answer to number 4. All right, let's take a look at number 5. For number 5, I'm going to group together these two binomials, and I'm going to multiply those together using FOIL. All right, so first would be n times n, which is n squared. Outside would be 3 times n. Inside would be 7 times n, and then the last would be 7 times 3. And then I can combine these like terms in the middle, and that becomes n squared plus 10n plus 21. And now I'm going to involve this n minus 9 binomial, and I'll multiply it times this FOIL result. So I'm going to distribute, the way this works is you'll be distributing both of these, the n and the 9, the negative 9. So distributing n first, you would get n times n squared, that's n cubed. N times 10n, that's 10n squared. And then n times 21 is 21n. And now I'm going to distribute the negative 9 times all three. So negative 9 times n squared. Negative 9 times 10n, it's negative 90n. And then negative 9 times 21 is negative 189. And now I'm going to see if I have like terms that I can put together. So there aren't any other n to the 3rd terms. So I'll just mark that one out after I include it in my answer. 10n squared minus 9n squared is positive 1n squared. Mark that. And then I've got a pair of n's that I can combine. So 21n minus 90n, that's going to be negative 69n. And then finally, I've got this constant on the end of this expression, negative 189. And so that ends up being my final answer for number 5. Number 6 is subtraction, but you have to be careful with subtraction. I always recommend that you treat this as a negative 1 that's going to be distributed to each one of these terms in the second polynomial. So dropping the parentheses, I'm going to end up with x squared minus 5x plus 2, and then distributing negative 1 to each of these three, I'm going to have negative 3x squared minus x plus 1. And then I combine like terms. So 1 minus 3x squared is negative 2x squared. Negative 5 minus 1x is negative 6x. And then 2 plus 1 is 3. And there's your answer for number 6. All right, so for number 7 on your test, I gave you an example of a test problem. You're going to need to make Pascal's triangle through a certain point. And for this problem, I need to make sure I go far enough to cover this binomial being raised to the 5th power, which means I need to go to the row in the triangle that has 6 numbers on it. So there's row 1, row 2, row 3, row 4, there's row 5. So I need to go to the row that has 6 numbers, and so I need to go one more. 1, 5, 10, 10, 5, 1. Okay, and these numbers represent coefficients, and here's how the expansion works. I take the first number from the row. I'm going to multiply the first term inside the binomial, which is 2n, and I'm going to raise 2n to the 5th power to start with. Notice how I put parentheses around 2n. I think that's important. It's a good reminder to make sure you raise both 2 and n to the 5th power. And then I'm going to raise negative 6 to the 0 power. All right, so that will be term number 1 after we come back and simplify. Term number 2, I'm going to do 5 times 2n raised to the 4th power times negative 6 raised to the 1st. Term 3, I'm going to do 10 times 2n raised to the 3rd power times negative 6 raised to the 2nd. Term 4, 10 times 2n raised to the 2nd power times negative 6 raised to the 3rd. Term 5, 5 times 2n raised to the 1st, negative 6 raised to the 4th. And then finally, term 6 will be 1 times 2n being raised to the 0 times negative 6 raised to the 5th. And now we're going to simplify this to get to our final answer. So term 1 is going to come out of multiplying all of this together. So 2 to the 5th times n to the 5th is 32 n to the 5th. And of course, negative 6 to the 0 is just 1. All right, term number 2. I'll do this. I'll do a little work up here. 5 times 2 to the 4th times n to the 4th is 16 n to the 4th times negative 6. All right, so might want a calculator for this. 5 times 16 times negative 6, and that's negative 480. So this second term is going to say minus 480 n to the 4th. All right, term number 3, it's going to be 10 times this 2 to the 3rd times n to the 3rd is 8 n to the 3rd. And then negative 6 squared is 36. So I multiply all these together. 10 times 8 times 36. And I get 2880 positive. So this is going to be 2880 n to the 3rd. And it's plus because all of this is positive. Now term number 4, I'm going to multiply 10 times 4n squared times negative 6 raised to the 3rd power is negative 216. So I multiply all this together. 4 times 10 times negative 216. And I get negative, so my next sign will be minus 8640 n to the 2nd. All right, term 5. 5 times 2n, and I just have to know what negative 6. Be careful here because when you raise a negative number to an even power, it should end up being positive. So negative 6 raised to the 4th power should be 1296. And now we're going to multiply that times 5 times 2, or times 10. And that's 12,960, and it's positive, so this term is plus 12,960 n. And then finally, 1 times 1 times negative 6 raised to the 5th power. And that's negative, so this sign will be minus 7776. All right, so the black is my final answer for the expansion of this binomial raised to the 5th power. All right, so let's take a look at this, this problem that really captures pretty much all of lesson 3.1 in one problem. So let's get started. We already have this quadratic equation function in standard form, so that means finding the y-intercept is pretty easy. I just look at this number on the end, and the y-intercept is negative 3. And I'm going to go ahead and just put the information on the graph as I come up with it. So that shows a y-intercept of negative 3, a red dot. All right. Letter B is identify the equation for the AOS. Well, the AOS formula is the opposite of B over 2A. All right, so let's identify what is A. A is 1. B is negative 2. We don't need C, but we'll go ahead and put it because we'll use it maybe later. C is negative 3. All right, so to get the equation for the AOS, first of all, it's x equals some number. And the number coming out of this formula will be the opposite of B, which is negative 2, over 2 times 1. So negative 2 over 2 is negative 1, but the opposite of negative 1 is positive 1. So I'm going to go ahead and sketch out the line x equals 1, illustrating the AOS. And that means when I come down to C and I'm looking for the vertex, I already know what the x-coordinate of the vertex is because these are the same, always. Whatever the AOS is, that's the x-coordinate of the vertex. So to get the y, just plug 1, in this case, whatever the AOS is, plug that back into the function for x. And that'll tell you what the y-coordinate of the vertex is. So 1 minus 2 is negative 1. Minus 3 is negative 4. So the vertex is the point 1, negative 4, which is that point right there. And because of symmetry, since I already know where the y-intercept is, I can match that up on the other side of the AOS, and now I have 3 of the 5 required points. Letter D is there a maximum or a minimum? Well, you can already tell just from the graph that this is going to open upward, meaning the vertex is at the very bottom of the parabola, so we're going to have a minimum. And the value of the minimum that it's referring to is this y-coordinate of the vertex. So the value of the minimum is going to be negative 4. All right, and now let's go ahead and find out what the graph is so we can get the answer for letter E. So the letter E says to use the graph. Well, we don't have a finished graph yet, so let's just go ahead and get points 4 and 5. So I'm going to let x be 3. Okay, I don't have a point currently for x is 3. So let's put 3 in for x and see what we get. So that's 9 minus 6 minus 3. 9 minus 6 is 3 minus 3. That's 0. So the point 3, 0 is part of the graph. And because of symmetry, I can come over here and match that up. And now I have a completed graph. Go ahead and connect our 5 dots. Now, what's this letter E talking about? The graph shows us solutions by indicating x-intercepts. X-intercepts means where does my graph cross the x-axis? Well, the graph crosses the x-axis at -1 and at +3. And so that's my answer for letter E. It's basically solutions to the equation are x-intercepts for the graph. And so I have my answer then for letter E based on the graph. And then finally, domain and range. We know that the domain for every parabola is all real numbers. And the range will be the y's that are bigger than or equal to -4. So it's greater than or equal to because the parabola opens upward. All right, now let's do some operations with complex, pure imaginary numbers. So this is, again, subtraction. So we had a problem kind of like this before where we distributed -1 to the second expression. So -1 times 7 is -7, and -1 times 5i is -5i. And then I just combine the like terms. 3 minus 7 is -4, and -2 minus 5 is -7i. And there's your answer for number 9. Number 10 is a FOIL problem. So 3 times 5 is 15. Outside, 3 times -6i is -18i. Inside, 5 times 4i is +20i. And last, 4i times -6i is -24i squared. But we've said this many times, I squared is equal to -1. So in place of I squared, I'm going to put -1, and that causes this to become positive or plus 24. Now I'm going to combine like terms. So 15 plus 24 is 39, and -18i plus 20i is plus or positive 2i. Number 11, I'm going to change the square root of -49 into its simplified radical form, which would be 7i, or actually just simplified form. And now I can multiply. Previously I couldn't. I can't multiply 6 times a radical, but now I can multiply these two together, and I would get 42i. So the only problem with this is complex numbers have to always be written in this form, and this is backwards. So I need to turn it around to put it in the proper form, and then I'm finished. All right, for number 14, number 12, get a little ahead of myself. We're going to put -1 in place of I squared. All right, I squared gets replaced with -1. So that makes +3 in the parentheses. So now I can multiply those together, and I get my final answer of 15i. For number 13, if you ever see a complex number in the denominator, then you're going to need to multiply by its conjugate, which means you just change the middle sign. I'm going to multiply by 3 minus 5i. Distributive property on the top, 4 times 3 is 12. 4 times -5i is -20i. You could do FOIL on the bottom. 3 times 3 is 9. 3 times -5i is -15i. And then 3 times +5i is +15i. And this always happens with conjugates. Those two inside, the O and the I part of FOIL will always cancel out. So now just do the last. -5i times 5i is -25i squared. But again, remember that I squared is -1. So when you replace I squared with -1, it makes this become -25 times -1, which is plus 25. And we end up with this. And now I'm going to ask you to break this up into two different parts. two different fractions. One will be real, one will be imaginary, and then reduce if you can. We can in this case because we can divide by 2. 12 divided by 2 is 6. 34 divided by 2 is 17. And this would be 10I over 17. So there's my final answer for number 13. Number 14, I always want to use a number I with a multiple of 4 exponent when I simplify these powers of I that are kind of big. So using I to the 24th power means that that's just equal to 1. I raised to any multiple of 4 is equal to 1. And so it's just a matter of knowing what I to the third is, but it's just I squared times I. I squared is -1 times I. So I to the third is just -I. And now when I multiply these together, I get -I as my answer. All right, 15 is another multiplication, so just multiply the coefficients here. 2 times -4 times 6. -8 times 6 is -48. And then you could go ahead and do I times I, which is I squared, but that's -1. And -1 times I is -I. And so our final answer here is 48I. You could have also, just giving you another option here, if you multiply these together first, that would be -8I squared. But -8 times -1 is +8, and 8 times 6I is 48I. So two different ways of coming up with that answer. And then number 16 is just straight addition. 4 plus -6 is -2. And then -3I plus 2I is -1I. Be careful, some people will be tempted to do FOIL here, but FOIL is strictly for multiplication. This is not multiplication here, obviously. So when you see addition between these two complex numbers, you just combine the like terms. The two real numbers go together, and then the two imaginary numbers will go together. All right, number 17, we're going to solve for x, get x by itself by first subtracting 27 from both sides. And now to get x by itself, I'll need to do the square root of both sides. That turns my equation into, don't forget, when you do the square root of both sides of an equation, you have to include plus minus. So now I just have to simplify the square root of -27, and here are my radical factors. These radicals together, multiplied together, will equal this one radical. So this leads me to how to simplify. The square root of 9 is 3. The square root of -1, that's the definition of I. That's what I is. And then I've got this other radical, the square root of 3. That cannot be simplified. So there's my answer for number 17. All right, number 18, solve by factoring. For number 18, I just need to know the factors of -15 that add up to -2. And that would be -5 and +3. So please, on these problems on the test, don't just stop with your factoring. Let the factoring help you solve. Solve means find out what x is. In this case, there's 2 x's, always for a quadratic. So think of each of these equaling 0, like 2 little equations, and then you can solve for x. All right, and then number 19, since the number in front of x squared is bigger than 1, we're going to do the box method. So you'll be told to use the box method when applicable. Well, here's when it's applicable, when the number in front of x squared is greater than 1. So those two multiplied together would be negative 10x squared. And I need the factors of negative 10x squared that add up to negative 3x. And that would be negative 5x and positive 2x. Now I do the GCF, so going across the top row, that would be x, and across the bottom would be 1. This first column, that would be 2x, and then this would be negative 5. So here's my factoring. And then I'm going to let the factoring lead me to the solutions. So each of the factors that have x, which is both, will equal 0, and I'll solve each one. So one of my solutions will be negative 1, and the other one will be 5 halves. All right, number 20, completing the square. So the first thing I will do is get rid of the plus 8 and replace it. So the way I get rid of plus 8 is subtract 8 from both sides. And the number that replaces the original 8 will be always divide by 2. So I'll just give you a little process here. Whatever's in front of x, divide by 2. So that would give you negative 1. And then you're going to do negative 1 squared. And that's what will go in both of these blanks. So divide by 2 in front of x, and that result gets squared. And that number that completes the square will be added to both sides. And now we have a perfect square trinomial, and it factors like this. The first term is the square root of x squared, and the last term is the square root of 1, and that sign just goes between them. And negative 8 plus 1 is negative 7. Now we do the square root of both sides. Don't forget plus minus. And now I'm going to simplify. You should never leave a negative number under a square root, so use the number I to simplify in cases like that. And that's our answer for number 20. Number 21, same deal. I'm going to move 11 over by subtracting. The number that completes the square, divide by 2. That's 2, and then 2 squared is 4. So I'm going to add 4 to both sides. The factoring will be the square root of x squared goes here, the square root of 4 goes here, and then just put that sign, whatever that first sign is, the sign in front of x, will go between them. And then negative 11 plus 4 is negative 7. Square root of both sides. Don't forget plus minus. And so the square root of negative 7 is I times the square root of 7. And then we'll subtract 2 from both sides. And we have our 2 solutions. Okay, 23, don't forget the quadratic formula. So here it is again. If you haven't committed it to memory, you still got an opportunity. Negative b plus minus square root of b squared minus 4ac. All of that goes over 2 times a. So a is 1, b is 8, and c is 5 in number 22. So let's solve for x. The opposite of b plus minus the square root of 8 squared minus 4 times 1 times 5, that's 20. All of this goes over 2 times a, 2 times 1, which is 2. All right, and now let's work on simplifying. So under the radicals, 64 minus 20 is 44. And don't leave a radical when it can be simplified. You need to know how to simplify radicals. That's why we did the chapter 0 lesson. So this is going to be, I'll just show it longhand. This will be the square root of 4 times the square root of 11, which becomes 2 times the square root of 11. And then I'll put my final answer here because these numbers, all of these numbers are divisible by 2. So we need to do some reducing here. So negative 8 divided by 2 is negative 4. 2 divided by 2 is 1 times the square root 11. And then, of course, you could put over 1, but it's not necessary. So that represents our two solutions, negative 4 plus the square root of 11, and then, of course, negative 4 minus. All right, and now let's do, before you can do the quadratic formula, you need to make sure it's in standard form first. So I need to add 10 to both sides, make it equal to 0. And now we're ready. So the opposite of b, plus minus b squared, minus 4 times 1 times 10, that would be 40, all over 2 times 1. All right, 36 minus 40 is negative 4. The square root of negative 4 is 2i. And then we can reduce because all of these are divisible by 2, and that's going to be 3 plus minus I as our final answer. 24. The discriminant is just this part of the quadratic formula, just that part, not the radical. And again, A is 3, B is 4, C is 6 if we're in standard form, which we are. So let's see, B squared is 16 minus 4 times 3 times 6. All right, so 16 minus 4 times 3 is 12 times 6 is 72. So the answer for the discriminant will be negative 56. So since it's a negative, and I'm not guaranteeing it'll be negative on the test, so you need to know how to answer based on whether it's positive, negative, or 0. But since it's negative, that tells me I'm going to have two imaginary, or you could say complex. All right, and then for number 25, we have this linear equation word problem. So linear equation means y equals mx plus b. We just have to identify what is x going to represent and what will y represent, and then it should be pretty easy to model this situation. This is really called modeling in algebra. Model a real life situation using an equation. So we're told that she earns $35 flat, and then the rest of her pay will depend on how many pamphlets she delivers. So I'm going to let X represent the number of pamphlets she delivers, and then Y will represent her pay. And so when we put that all together in Y equals mx plus b, she gets 17 cents for every pamphlet, which we're saying is X. And then she gets this $35 regardless of how many pamphlets. So that's going to be the answer for part A. And then for part B, we just put 300 in place of X. And don't forget to add 35, and we'll just go to our calculator and find out how much money she's going to make if she delivers 300 pamphlets. And add 35, and that is $86. And that is your answer for 25A and B. All right, let's move down to number 26. And this is a system of linear inequalities. So we'll need to solve each of these for y so we can prepare for graphing. And then the solution to this will be where, if these two shadings actually come together, do they meet in a certain area on our graph paper. So let's get these solved for y first. So I need to subtract 6x from this first inequality. And then I need to divide by negative 2. So be careful because we're dividing by negative, which means we have to reverse the inequality sign. And so negative 6 divided by negative 2 is 3x, and then 12 divided by negative 2 is negative 6. So we'll go ahead and sketch this graph. So negative 6 on the y-axis, and then a slope of positive 3, up 3, right 1. And looking at the inequality, because it says or equal to, then we make a solid line. And then our shading, less than always indicates below or beneath. And I won't do the shading yet. I'll just indicate with arrows where the shading will be. And now let's prepare this bottom inequality for graphing. So get it solved for y. I subtracted 3x from both sides. And now I'm going to divide by 4 on both sides. And now I graph, so y-intercept of 3 and a slope of negative 3/4, so you can do up 3 with left 4, or down 3 combined with right 4. And this line is going to be dotted because it doesn't say or equal to. And it's greater than, so that means I'm going to shade the upper side, or greater than means above the line. So you can tell where I'm going to shade overall. My final solution will be where the red and the black actually combine, where they collide. And that's going to be this area right up here, top right. Everything that is both below the red and at the same time above the black. And there's your answer for number 26. 27 and 28 are evaluating functions for certain inputs. So if we input negative 3 in this function, we have to tell what would come out, what's the output. So negative 4 times negative 3 is 12 minus 8. So the answer for f of negative 3 is positive 4. And then over here, we're going to evaluate g of 5. Input 5 in place of x. And evaluate, or see what the output is. So 5 squared, make sure you do exponents first. 5 squared is 25. 25 times negative 2 is negative 50. And then this will be minus 20, and then plus 1. Negative 70 plus 1 is negative 69. Now our final two problems are transformations of parents. And so this is the absolute value parent. This is the quadratic parent. So the absolute value parent originally started here, looked like this, where my red dots are. But the black represents what we call a translation of that parent, which means a shift. And putting the two moves together, we went left 2. All right, so the way I show a left or right shift is I put either plus or minus inside the absolute value bars. And the horizontal shift is always the opposite of what you would think, so you have to be careful. So actually, to show a shift of 2 to the left, I'm going to say plus 2 in the inside. And then the vertical shift will be outside. So I just go outside the absolute value, and to show up 3, I add 3, or plus 3. Well, there's the answer for 29. And then for number 30, this is the quadratic parent. So to show that I went from the parent, which both of these parents start at the origin with their vertex, I went right 2. So that's going to be x minus 2, up 3, still plus 3. But it's flipped over. The original parent, just rough sketch, would be opening up like that. Well, this is upside down, which means we have to have a negative in front of the parentheses to make it It's called a reflection. So those are all your problems that you will be required to do, problems like that on your test coming up. So I hope this helps. If you have any questions, reach out to me, and I'll see you next time.